All right. Hello, everyone. Thank you very much for coming today. I wanted to introduce myself. I'm Ellen Shapiro. I am a native mobile developer. I work at a company called Bakken and Beck. I work in the Amsterdam office. We're headquartered in Oslo. We also have a primarily machine learning driven office in Bonn, in Germany. And I have been a native mobile developer for a while. I build iOS and Android apps with Swift and Kotlin, just like so old-fashioned actual native mobile development. And I do a lot of writing and speaking about iOS and Android and Swift and Kotlin and all that kind of stuff. But today I'm here to talk about a somewhat different but related topic, and that is quality assurance. So let's start with something a little bit more basic. What is quality? There are a lot of things that people could mean when they talk about quality. They could mean the quality of the code and the architecture that underlies an app. They could also mean the ability of an app to be resilient to change at an operating system level. What they could mean is that an app has clear and obvious ways for users to accomplish their goals. Did you tell them? No? Okay, tell them. But when I'm talking about the world of QA in mobile apps, the biggest thing I want to focus on is defining quality as whether the user can actually do all the things you intend for them to be able to do with your application. All of these other things are important to quality, but if the combination of those things doesn't add up to something that actually lets users do what you tell them your application can do, none of those other things matters. So now that you know what I mean when I'm talking about quality, what is QA? What is quality assurance? Now, I am obviously not here to try to answer this question for everything in the world, because between different industries, particularly even between software and hardware, it can mean really, really different things. What I want to talk very specifically about with QA is what QA is in the context of mobile software development. And even in this far more limited context, you get a lot of different answers depending on who you ask about what quality assurance means. If you ask project managers, sometimes they can be a little bit overly optimistic about what QA does. They can think, these are the magical people who make sure we never ship bugs. And sometimes they can also get a little bit cranky with QA engineers and think that these are the people who prevent us from hitting our deadlines. Because QA can sometimes catch things at the last minute, throw everybody into a panic. But if you turn around and you ask developers what they think about QA, they tend to think of QA as the people who break my app. Some sort of sadists who really enjoy taking this beautiful thing you've been working on and shattering it into a million pieces. And they also sometimes get frustrated because QA can be seen as nitpickers, people who focus really, really hard on details and can occasionally get a little stuck on them. Honestly, all four of these descriptions are correct, because really, what quality assurance is for mobile development is making sure that there is a last barrier between you and breaking something for your users. When you mess something up in your application, you want to make sure that you are not going to have an angry mob that shows up on your doorstep demanding to know why your app isn't working. I've done this. It's not fun. And so I tend to think of QA, and today I'd like to argue that most developers should think of QA as the people who save my ass, the people who are there to help make sure that through rushing or ignorance or carelessness, I don't screw something up for my users. They are a bit like a goalie who, with an absolutely killer save, snatches victories from the jaws of defeat. And while QA engineers do have a tendency to err on the side of pessimism, that actually turns out to be a really good thing. Because in the end, I've never seen a problem that was worse than QA thought it was going to be. If you think QA is nitpicky, your users are 1,000 times worse and are generally way less polite and clear about anything they find insufficient. If you think QA has come up with a way to break your app that would never happen in the real world, I guarantee you someone, somewhere, has found a way to break it in an even less expected way. So who are these mythical people that have come to save you by breaking your toys? They are QA engineers. A quality assurance engineer is someone whose job is dedicated to make sure the app is always shipping in a workable state for your users. How do they actually do that? Well, they sit down with the application that you've built and they try to use it. they try to use it the way that an actual user would, potentially several different kinds of users. And inevitably, they will break something, because it's software, it's never perfect. But when they break something, they take a really critical extra step. They tell you how they broke it so you can fix it. They give you the context you need as a developer to understand if something is indeed a bug, or perhaps a feature isn't clear enough to first-time users, or maybe some kind of hiccup in the back end caused a really temporary issue. Because every one of us that's a developer here has gotten a really fantastic bug report from a project manager or someone else in our organization. I can't log in. This is really annoying, because then you have to spend forever going back and forth with this person, trying to figure out, okay, what do you mean you can't log in? When you get a brand new QA engineer, someone who hasn't really done it before but sort of understands the point of what they're supposed to be doing, they start to add a little bit more context to what they did. Their tickets look a little bit more like this. I went to the login screen, I entered valid credentials, I tapped on the sign-in button, it looked like it was logging in, but nothing happened. This is more helpful. You have at least got confirmation the user was able to get to the login screen and put information in, and that's when something didn't work. If you get a really experienced QA engineer, you get tickets that look like this. On a build pointed at the staging server, I entered valid credentials, here's my credentials. I tapped on the sign-in button, the loading indicator appeared, then disappeared, I was not logged in, and no error was displayed. These are the devices that I tested on with the operating systems that they're running. This is a ticket that specifies exactly what's happening, what environment it's happening on, and how to reproduce it. Often it'll also, I didn't have room on this slide for it, but often it'll also give you lots of information about how frequently something happens. So you can help prioritize bugs that are happening all the time versus bugs that are really only happening occasionally. Ticket writing is a really important thing that QA engineers do. But there's something that I think they do that's far more important from an organizational standpoint. They help you actually answer and document the answer to a really critical question. What is this app supposed to do? And this covers everything from what are these screens supposed to look like to this is what should happen when you press that button. And QA engineers, when they first come into a project, will usually start by creating test plans based on whatever documentation they can get their hands on regarding what things are supposed to happen when. They make a list of these things so that when they get ready to test your app, they have a plan and a checklist to figure out whether these things are actually happening or not. I've worked in a lot of places where, especially if you're coming in after an MVP phase, where things were just like shoved out the door as quickly as possible, the only documentation that exists of an application is the existence of the application. Sometimes there's information that's sort of slowly been passed down by the many generations of project managers just saying something nice as they walk out the door with their middle fingers in the air. But having to sit down and figure out, okay, what is this app actually doing now? This forces both developers and product managers and designers and UX people to step back and look at the entire app. Take a holistic view of what is happening in your application. And this is a really great way to find inconsistencies, especially if an app has gone through a number of sets of hands before it got to you. When you take that higher level view, QA engineers are also able to help you identify what are the pieces of your application that can ship with a minor bug, or pieces that have to ship with as few bugs as humanly possible. What are the absolute mission critical parts of your application? And how do I prioritize things when I find something wrong? Another great thing about QA, big piece of their job is to keep looking at the app, just keep watching the progress of the application. They see the entire app on a regular basis in a way that developers, designers, and project managers often don't. Devs see the pieces that are being worked on. Designers and UX and PMs often see just this bright future of the app and they forget what's actually out in the store right now. QA engineers see what is going out the door to users on a day-to-day basis. They can help you by flagging whether new UX patterns or new design patterns which are being introduced are helpful or not. And working with QA engineers forces you to define your priorities. How important is it to get something out the door versus not breaking something that is already out the door? It usually depends on what that thing is. And QA will often work with project managers on their test scripts to determine what bugs are actually showstoppers versus which ones are kind of up for discussion and then those that can just be punted. And you have these discussions constantly whether or not you have QA. Having QA forces you to have them in an organized and defined manner so that those decisions are easier to make under a tight deadline. So now that you know some things that QA can do for you, I want to talk a little bit about the different kinds of QA testing. There's two primary types. And there's some people who do both things, but often people will specialize in one thing or the other. The first, most common one is manual testing. Going through, poking at the app manually. There are some things that this can find incredibly quickly, especially from a UI standpoint, that are almost impossible for a more robotic test to find. I'll talk a little bit more about that in a couple of minutes. The downside of manual testing is that especially as an app gets larger and more complex, this can get really time-consuming and frankly kind of boring. So often, the testers will take the pieces that they have to do over and over and over again and automate them. And this is where we get into tests that are written in code, software testing. The app is still being tested on a real live network, sometimes on a real device. Tests are written in code and can be run at any time. Now, these tests can still be somewhat time-consuming to run. They're definitely faster than an actual person sitting there and inputting all this information. Because they're time-consuming, they're often run overnight on all the code that changed over the course of the day. It helps you find out much, much faster, hey, this thing that I thought was working, not so much. They're also often run as a final dummy check right before the application is released. And I'll talk a little bit more about that type of testing in a bit. Now, particularly when people hear about software-based QA testing, they have a minor tendency to get a little smug and say, we don't need developers, or we don't need QA. Our developers write automated tests. And when people talk about this, they're talking about unit tests and occasionally UI tests written by developers. And if you have those, well, that's great. They're definitely a great way to prevent regressions and possibly prevent bugs. They are a good start that will help you get the most out of the QA engineers that you're working with. I apologize if I butcher your name. Tomas Bocinik from Perform yesterday pointed this out when he was talking about using Gherkin for behavior-driven development. The plain language Gherkin tests can serve as a point that launches your QA testing. But Tomas was very careful to never say that you can replace QA with this kind of testing. When you think about developer-written automated tests, you need to be aware of where the holes are in your coverage. Now, I'm not talking about looking at your code coverage report, because that can say 100%, and stuff can still not work the way that the user thinks it's going to. So the first thing that you need to be aware of, first thing you can do that, is ask what kind of automated tests do we actually have? Because people talk about automated tests, they're often talking about different things. So I want to clarify a couple of types of developer-written tests before going back to my main point. So the main type of tests I hear people saying they write are unit tests. They ensure the correctness of a single piece of code, usually run before every pull request is merged. And they're usually super, super fast to run. You can run thousands of them in like a second or two. The limitation of unit tests is that they don't cover how different pieces of code work together. So for that, developers often move up to something called integration tests. And this is usually tests without any UI about whether pieces of code that are supposed to work together actually do work together. And this is really helpful for things like making sure your entire parsing path from the network all the way down to the database is actually doing what it's supposed to, or making sure that like the Bluetooth manager and the location manager are playing nice with each other. There comes a point, though, that there's only so many pieces you can test without actually just using the application the way that you would in the real world. So the next step up the chain in developer-written tests is UI tests. For iOS, this is something like XCUI or KIF or Earl Grey. For Android, it's almost always Espresso. And as a developer, you get access to the screen, tap through anything the way that a user would. Usually, you mock out the networking layer so that you can test that the UI responds to data received from the network in a known way. The problem with UI tests is that they only test the app in the way that the developer thinks it's supposed to work. I may think an app is working perfectly fine according to the requirements. The designer or the project manager may think very differently, and they will quickly see that it doesn't do what it needs to do for the user. That mocked out networking that helps ensure stability for UI tests is a double-edged sword. It's really helpful from a perspective of separation of concerns and reliability, but it can miss major issues when the app either has no network connectivity or loses connectivity in the middle of an operation. The other thing about all these developer-written tests is that they're all run robotically. They're code that tests other code, and there's no point at which any human gets involved during the test run unless something goes super duper wrong. Thing is, when you're looking at an app, humans and robots find very different issues. There are lots of things that robots can be good at spotting, but the humans are absolutely terrible at, and that is what developer-written tests are often very good at catching. But there are a lot of things that only humans can catch because of a very fundamental truth. Humans are deeply, deeply strange creatures, with habits far weirder than most developers imagine. Humans love tapping screens. They definitely do not love tapping those screens in the places or the order in which developers would prefer they do so, or in the order in which their code assumes they will do so. Bugs love to live in this area, because it's really, really hard to write automated tests around this. Really great QA testers have an uncanny ability to understand what the operating system or other applications that are far more popular usually ask of a user, and how a user would use the app based on the assumptions that they have gotten from those other places. Another thing that can be really, really difficult to test in an automated fashion is the constant way people exit and enter apps. I open my text messages, I get a push notification from your app, so I tap on that. But while I'm waiting for the app to get past the loading screen, another push notification comes in and I tap on that. And I've left your app in an almost done setting up state, but not quite. This is behavior that's really, really difficult to replicate without a human, and which can lead to some super, super weird bugs. And having testers who actually use the app like a normal human being is critical to finding out some of these issues before you send them out to your users. Another thing that automated tests can only test in a limited capacity is how people try to use your app when either knowingly or unknowingly the user reaches the absolutely terrifying point of not having an internet connection, or even worse, having one that's total garbage. You could theoretically mock out your network state, but you always have to pick a time for your network to drop out. In reality, it drops out when you go out of coverage, not necessarily at any point where it would make any sense. All of these things are far easier for a human to test than a robot. And this is where having manual testers comes in really handy, because humans are far more capable of emulating the stupidity and or insanity of other humans than robots are. And this is when you first start to encounter dedicated QA engineers as manual testers. Because while the software engineers who wrote the code are very much capable of testing their app manually, they also generally have a million other things on their plate. Dedicated manual testers are the people whose job it is to poke through the app, not so developers don't have to, but so that they have to do it less often, or so that when they're slammed, they know that the app will still be poked through. But one thing I've definitely noticed is that manual testers seem to get a lot more crap from developers than testers who write code. Manual testers often are looked down upon because their technical skills do not include writing code. And this can lead to developers and QA not really trusting each other, just eyeing each other very warily across the room in case somebody makes a sudden move. And sometimes this can even reach a point where some QA people are afraid of developers, afraid to come anywhere near the code the developers write, especially if developers treat QA people like they're dumb. But particularly with manual QA, it's really helpful to remember that in order to be good at your job, it takes the same kind of mind that loves to tinker with things and take them apart to see how they work that it does to be a good developer. In fact, one of the things I've seen be the most successful in getting QA and developers to have empathy for each other is to actually help them learn more about how your app works under the hood. By doing this, you help reduce your QA team's fear of code by helping them understand that. But again, the bigger thing you get than reduced fear is increased empathy. As a developer, you're able to have more empathy towards QA people as humans because you're able to communicate with them in a context that you're more comfortable with, and you're able to help them do things and answer questions in a way that when you're sending text back and forth on tickets doesn't always work. It also helps QA people have empathy for developers, especially when they can look and see the difference between code that's a total mess and something which is clearer. You do not have to have the ability to write or understand code to be able to look at certain pieces of code and go, wow, that looks really complicated. So how can you help QA people get set up with the basics? The first thing that they need to do is to be able to get code running on their local machine. You don't have to show them command line, but you can teach them a little bit about Git. That'll allow them to pull whatever the most recent version of the application is, have it on their computer. And again, you don't have to teach them everything about Git. You can even just say, here is source tree, here is the button to pull, here's the button to discard existing changes, and here's the button to check if there's more changes. You can also get them set up with Android Studio or Xcode so that they can actually start poking around in the code a little bit and running the application on a local emulator or simulator. This is also a really, really good way, by the way, to find out what parts of your setup, if you haven't hired a new developer recently, are way more complicated than you realize they are. And doing all this setup and helping these people get started with this lets these really analytical minds start to look at the structure of the application and learn more about it. You can encourage ambitious QA folks to start making basic fixes to your application. Copy changes are awesome for this because if you've got all your copy localized, it's all going to be in one file, so it's really easy to find. It's really, really gratifying for QA engineers to see code that they wrote, even if it's just replacing a string, make it into the app. And for developers, it is a massive time saver when QA was able to fix things like typos themselves. It's also something which can get QA engineers interested more in working with software. So there's two things that can come with that. The first, which is somewhat rarer and definitely more time-consuming, is when a QA engineer gets really excited about a particular platform and actually learns how to code for it and starts building things with you. Now, particularly when you're hiring and you've noticed that it's really competitive and difficult to hire experienced software engineers, and hiring junior software engineers is kind of a crapshoot. Getting a junior who at least knows what your app is supposed to do and has a decent idea of its basic structure is a really great way to get a junior who still needs some support but is at least well-versed in what you're trying to do. So a really great example of this is the head of the QA department at the last job I had before I moved to the Netherlands. He started by doing the kinds of fixes that I was talking about. Did an Android certificate course through Udacity. And then he started watching all of the Android PRs and asking questions and really talking more to the developers about code. And they started helping him with the side projects. He is now about to promote one of his underlings to run the QA department and take a job as a junior Android developer. As I said, this is a somewhat less common outcome, but it is amazing when it happens. A much more common outcome, and sometimes an intermediate step, is when QA engineers become less afraid of code, they get much more interested in using code themselves to make their job easier. And this is where the test cases that you've already come up with for manual testing come in really, really handy because it allows your QA engineers to start writing automated tests. And because they're used to doing everything from scratch as part of a particular test scenario, the type of tests that they tend to write are called end-to-end tests. These are longer tests that go through a long process and make sure every step in the process leads to the desired outcome. These tests hit a live server, usually staging rather than production, and are meant to make sure that the app works as a whole. They test things like, can a user create a new account and successfully make a purchase? And as long as the happy path is happy, all is well. When an end-to-end automated test fails, this tells the QA engineers, aha, this is a place where you need to focus your manual testing for these changes. Something that affects this has changed, and so you need to put more effort into manually testing this particular part of the app than those places where the automated tests are passing. This is a huge time saver when you have a big app and not a ton of QA testers. This can also be a really nice canary in the coal mine for developers to let them know, hey, this thing that you changed over here, that's breaking stuff way over here. A really advanced version of this is called smoke testing. Usually this is automated, set up to actually run on production so that any bugs that are caused by differences between production and staging are smoked out. These will usually take a particular subset of end-to-end tests with absolutely critical functionality, which again, QA has already helped you select and define. And it makes sure that everything still functions on that happy path. QA can also do manual smoke tests. Just having a last set of eyeballs go through a simplified script to ensure that all of your critical functionality is working is really helpful. Smoke tests are your last chance to find out if something is broken before you get the users with torches and pitchforks at your door. Now, in order to do any of the stuff that I've spent the rest of the talk describing, you have to do a bit of work to make it easier for QA to get builds to run their tests on. And it leads to something that helps a ton, which is called setting up a build pipeline. A build pipeline allows you to have a repeatable, automated process for creating builds so that every time QA needs a new build, a developer doesn't have to take time out of their day to make a new build and figure out how to get it onto QA's test devices. And one thing you need to do when you're creating a pipeline is figure out at what point do you actually need to get a new build to QA? Do you need to do it for every single commit? How about every single merge to master? What if you're running off of a long-running feature branch? How do you do that? The answer to all of these is going to be really dependent on the project you're working on, but it helps to have at least thought these questions through and made a setup flexible enough for builds to be kicked off and sent somewhere automatically without much or really any effort on the part of developers. Part of that flexibility is setting up a repeatable build process with scripts. You might have an array of scripts that are set up to run on a trigger. Maybe a particular type of continuous integration run completes. Scripts should, without human intervention, build your application for distribution from a known point and then upload it somewhere where it can be distributed. There are tons of services you can do this with. TestFlight, Crashlytics, and a number of other places offer this service. iOS Enterprise Cert users and Android users can sideload apps directly onto their devices. If you're looking for someone to do a bit of this work for you, there's a tool called Fastlane, which helps both iOS and Android developers build and upload their apps to various distribution services by using really simple Ruby-based configuration files. There's actually now some stuff that can be done in Swift as well. Taking the time to set up a repeatable pipeline means fewer interruptions for developers and fewer blockers for your QA team, something that vastly reduces frustration on both sides of the equation. So I've obviously given you guys a lot of the arguments in favor of using dedicated QA, but there are any number of arguments against having dedicated QA. And I have experienced a large number of levels of QA from, what? None. YOLO, ship it, to layers and layers and layers of testing before something can go out the door. So I feel like I can at least give a few responses based on having built apps professionally since 2011. The first argument I hear, and one I hear a lot, is that quality should be everyone's responsibility. This is absolutely true. However, when everybody is responsible for something, effectively, nobody is responsible for it. Having someone or a team specifically dedicated to ensuring a product works against a defined set of requirements helps make sure that we have a constant and clear idea of what the product is actually supposed to do at any given time, and that the product actually does those things. Now, the next complaint that I hear pretty often is that adding QA makes us go slower. This can be true. When it is, it's usually to the long-term benefit of the product. Going slightly slower and having a product that works when it goes out the door means less time working on things that should already be working and doing emergency bug fixes, and more time spent working on cool new shit. This is highly related to the next thing that I hear, which is that adding QA really makes it hard to change things. It can, but it also allows change to proceed in a more managed fashion. Having a clear set of tests for a given version allows developers to understand what they're aiming for per release, and forces some bits that aren't fully thought out to be thought out much earlier in the process. Now, working at an agency now, I hear a lot, well, this project is too small for QA. This can sometimes be true. You really don't want the full burden of a QA sweep for every single project that you're working on, especially when you're working on prototypes or minimum viable products that need to be out the door like 3 weeks ago. But once things get past the point of prototyping, and particularly once something has been released to the public, or is about to be, having QA is super critical to making sure that it works well and continues to work well, no matter how big or small the project is. I have seen users get even madder about a 2-screen app that doesn't work correctly than a giant app that doesn't work correctly, because they think because your app is so much smaller, you should be paying much more attention. Make sure that you have QA to help catch these issues before they reach users. So now that I've talked about a couple of straw men that have been thrown at me over the years, you're probably wondering, okay, there are clearly a lot of possible types of tests in QA, but how many of these actually need to happen? For this, I will turn back to the Twitter account of QA Hates You, one of my very favorite pseudonymous Twitter accounts, for an excellent definition. Minimum viable testing, which is the least amount of testing that can be done to prove to stakeholders that testing occurred to avoid job loss once defects are discovered in production. You have to figure out what's right for you, for your budget, for the size of your team, and for whether your goal is to get something, anything out there, or if it's to have an app that doesn't break for your users over the long term. I do have some recommendations on where to start. Starting with developer-written tests is a really, really, really helpful thing. If you don't have those, I would highly recommend creating some, because frankly, as a developer, I find my job is a lot easier if I have a robot going, hey, you broke it, even before it gets to any of the rest of this stuff. The next thing that's really helpful is having some kind of test plan. Creating a test plan is something that QA engineers can be really, really helpful with because they've had a lot of experience doing it, and they're very good at breaking a feature into its component parts. Having a plan helps you prioritize what features are mission critical versus what level of bugs you're kind of okay with them shipping with. Once you have a plan on what needs to get tested, start by having an actual human being poke through your app. Again, it is really, really helpful to have professionals doing this since they have experience writing tickets that help you identify and fix the problem much, much faster. People can also help you find bugs in places that automated tests simply can't. Once you start having large pieces of the app that don't necessarily change all that often, your testers can and probably will want to add automated tests, which act as the canary in the coal mine and tell them where to focus manual efforts because something in the changes is causing the app to break. They're still looking for those weird edge case bugs, but they're now able to focus on the weirder bugs because the obvious bugs will get caught by the robot. Oh, and of course, the bottom of every hierarchy pyramid nowadays has to be scribbled in Wi-Fi. But in each of those types of testing, whether you consider it QA or not, it really helps improve the quality of your application when it comes to how your users use it. And while some things are run automatically by robots and some things are done manually by humans, it helps to remember that robots and humans working together to break your app before your users do really leads to a higher quality application. And to have the robots and humans work together most efficiently, you need to have your QA engineers and your developers trust each other and respect each other. Maybe not groom each other. But once that happens, your app cannot help but get better. So we have now reached the fabulous time of the obligatory summary slide. I want to just hammer on a couple of things before I throw it to questions. QA helps catch problems before they reach users. I have dealt with applications with anywhere from 0 to about 300,000 users. Any number of those users showing up and going, "You broke my app," is very frustrating to deal with. Find out when something's going to break before it goes out the door. QA forces clarification of existing process. This is something that I didn't expect to be a benefit of working with QA, but I have absolutely found that anytime I work with QA, it is far clearer what the finished product is supposed to look like than it is when there's no QA. Unit and UI tests are awesome, but they are not a replacement for QA. I have seen companies try to do this, and this is when you get a ton of bugs in ways that are just not testable by robots. Start with manual QA, work your way up to end-to-end smoke tests. There are some people who try, not unlike developers, saying, oh, well, if you're going to have testing, you have to test literally everything, or you're not doing it right. The thing about that is that it's so self-defeating. And that's the same thing that you run into with QA. You can eventually get to this point where you have a complete coverage of your application and you're really confident anytime you hit that release button. But it is better to have somebody doing something than nobody doing anything. Empathy between QA and devs is critical to success. Talk to each other. Make sure that you remember that on the other end of the ticket that says, hi, this thing, I can't put my email into it. There's a person on the other end of that. There's a person who's usually a very curious person. There's usually a person who is interested in picking things apart and figuring out how they work, just like you are. And that's it for me. So thank you all very much.